Welcome to Unit 3, Lesson 7, Solving Rational Equations, Part 2. The original video was too long, so I had to break it into two parts. I only get 15 minutes per video. So, all right, we're working on problem number 3 here. Okay, so we're going to do this on each page. All right, so the first thing we're going to do, identify all values of x that make the equation true. Cross multiply, we get x squared equals 25. Now, when you solve an equation, the coefficient, the number out front, must be positive 1. The exponent, the number to the top right, must be positive 1. Because this is squared, we have to do the square root, which is the opposite of squaring. So what we're going to do is take the square root of both sides. When you take the square root of a number, you get two answers, one positive and one negative. So when you take the square root of a positive number, you get two answers, one positive, one negative. And these both work because the only number x cannot be is 0. The denominator cannot be 0, so this works. Okay, for B, crossing, multiplying again. We get x times x plus 2 equals 6x minus 3. Distributing, we get x squared plus 2x equals 6x minus 3. So, because this has a square in it, I'm going to have to move everything on the right side, make it equal to 0, so that I'm solving a trinomial. So I'm going to subtract 6x. I'm going to add 3 to both sides. I get x squared. 2x minus 6x is minus 4x plus 3. I have it equal to 0 because I moved everything off the right. Now, I take my factors of the third term. They happen to add to 4, so this is easily factorable. x1, x, and 3. This tells me the sign in front of the third term tells me they both had the same sign. This one tells me they're both negative. And so now I separate them and set them equal to 0. I get x equals 1 and x equals 3. Okay, again, the one thing our denominator could not be was 0. It could not be equal to 0. So there we go. Okay, now for C, same thing. We're going to cross multiply. We're going to cross multiply. We get x times x is equal to 3 times x squared, which gives us x squared is equal to 3x squared. I got to divide by x squared on both sides, because I want the numbers on the right and the letters on the left. 1 is not equal to 3. This has no solutions. And sometimes you get things like this in math. Sometimes things just don't work out. Okay, and for D, we're going to cross multiply. Get x times 6x squared plus 18x is equal to 5 times 2x cubed. We're going to distribute 6x cubed plus 18x squared is equal to 10x cubed. We're going to subtract 10x cubed because we want to put the letters on the left and the numbers on the right. Negative 4x cubed plus 18x squared. They both have something in common. What I'm going to do is I'm going to take out the x squared only. I'm not going to take out the common number. I could take out a common number, but we're not going to do that. So let's just take out the x squared. So if I take out x squared, that leaves me with negative 4x plus 18 equal to 0. X squared equal to 0 because I separate my factors and solve separately. Okay, x cannot be 0 because my denominator is 0. So this is not a solution. Is not a solution. All right, so now If I subtract 18 from both sides, I get negative 4x is equal to negative 18. When I divide by negative 4, I get x is equal to 18 over 4. I got to reduce my fraction by dividing by 2 over 2, which leaves me with 9 over 2. Now, had I not taken the 2 out earlier, I would have been left with 9/2. You can change it into a decimal if you want, but it's more precise to leave answers as a fraction. Okay, in this graph, g is equal to negative 4x to the 4th times the quantity x plus 3 are positive. How do we know? Well, what we do know is that positive x odd, if you have a positive coefficient and a exponent is odd, it starts low, it ends high. If you have negative coefficient x odd to an odd exponent, it starts high and ends low. So that tells me that G is the answer. You can always graph it, and make sure you hit the negative sign down at the bottom near the decimal point and don't hit subtract, because the calculator is going to give you an error. Okay, rewrite the rational function g of x in the form of c plus r over x. So what do? There's two ways to solve this problem. The first way, you could just separate the fraction. The same denominator, if there's an expression in the top, you can separate it. X divided by x is 1, which means 1 is our horizontal asymptote. This is how we find out horizontal asymptote. We learned this way back in lessons 3.3 and 3.4. We started talking about horizontal asymptotes. 3.2 and 3.3, we talked about vertical asymptotes. Or you could do long division. So if I do x goes into x minus 9, x goes into x once, change the sign, I get 0 minus 9. So I get 1 with a remainder of 9, that's over x, I get the same thing. And finally, all right, let's analyze this problem here. Elena has a boat that can go 9 miles an hour. That is a speed. As we read down, she travels downstream for a certain distance and back upstream. So that means her distance is the same. And next, Elena notices it takes 4 hours upstream and 2 hours downstream. So this is a time. So what we have in this problem is the same speed, the same distance in 2 different times. The river speed is r miles per hour. Write an equation that will help solve for r. So they're not asking us to solve for r, they're saying write an equation. So we need our distance, speed, and time formulas. Speed is distance over time. And if we make this a circle, we know that distance equals speed times time, because this means multiply, this means divide. So let's start with our time upstream. Our speed is 9, but we're going upstream, so we got to subtract the current, times it by the time, which is 4. Our time downstream is 9 plus r, because we're going with the current, times it by 2, which is the time. Now, since we had the same distance, we're going to set these equal to one another. 9 minus r. And then we solve for r and get the speed of the river. And then we can calculate the distance from there. But they didn't ask us to solve this problem. They only asked us to write an equation that will help solve for r. So we stop here. This is the last lesson in this unit, and we are done with unit 3.